In this screencast, I'm going to explain random number generation in MATLAB. The rand_n function can be used to generate normally distributed random numbers. The rand function can be used to generate uniformly distributed random numbers that are continuous between 0 and 1. The uni_drnd function can be used to generate discrete random numbers. The RNG function is useful to ensure that the random sequences that you generate are repeatable. And finally, the randperm function, to create random permutations, is very useful in setting up experiments that balance a certain number of trial in each condition while also having random variability. So let's take a look at these different random number generators. If we use the rand_n function and we give it two input arguments, so 1, 10, now we create a row vector with 10 elements, and all the elements in this row vector are normally distributed random numbers. I can run this function a number of times, and every time I get a different set of normally distributed random numbers. Now, similarly, the rand function, so I can say, let's say rand 1, 5. Now I get a row vector with 5 uniformly distributed random numbers between 0 and 1. Again, every time I repeat this command, I get different set of uniform deviates. So again, I can control these input arguments. If I say 2, 5, now I get 2 rows and 5 columns. Now suppose I want to generate discrete random numbers in a certain range. I can use the uni_drnd function. And the first argument is the range of the random numbers. So suppose I make this 4. And then I have the size of the matrix that I want to generate. Suppose I generate a row vector with 10 elements. So note here I get discrete random numbers between 1 and 4. And so I just happened not to draw any 4 outcomes. I can repeat this again, and now I see a bunch of 1s, some 2s, some 3s, and some 4s. If we want to generate random numbers that are either just 0 or 1, so if we want to generate binary outcomes, there's another way to do this by saying, okay, let's take the uniform random number generator, the rand function. Let's suppose I have a row vector of those. And now I compare that against 0.5. Every time I draw a uniform random number that's smaller than 0.5, then this outcome is true, otherwise it's false. And so the result is just a logical array of 0s and 1s. And these 0s and 1s are discrete outcomes, and they're randomly distributed. So there's a 50% probability that you get a 1 and a 50% probability of getting a 0. So if I change this number here, and if I now make this 0.8, now there's a 0.8 probability that I will draw a uniform number that's smaller than 0.8. And this is how you can control the probability of getting an outcome that's 1, that's true, as opposed to an outcome that's 0, that's false. And that's very useful for controlling random sequences in experiments. Now, if we go back to these continuous random numbers, so if we go back to this example, one issue is that every time I call the random number generator, I get a different set of numbers. In some circumstances, I would like to have my random numbers to be repeatable. For example, if you set up an experiment where the trials are randomly assigned to conditions, you would like the experiment to produce a repeatable random sequence. So that some participants, they get one random sequence, other participants get another random sequence. And so you can later investigate what is going on in the experiment. If something surprising happens, there might be a bug in your code. And so you would like the experiment to produce the exact same sequence of trials, the exact same sequence of conditions. Now, to force the random number generator to do this is to set the random seed. And so you can use a function called RNG, and we won't go into details here, but you can pass this a number. Let's say I pass it the number 1. That's my random seed. And now suppose I draw some random numbers. And now I draw some random numbers again, so I get a different set. But now I go back to setting the random seed back to 1 again. And now, again, I draw some random numbers. Here's the key result. Note that this set of random numbers is exactly the same as this set of random numbers. Because I've reset the random number generator, right? I gave it a certain seed, and based on that seed, the random number generator will follow the exact same sequence. So let's illustrate some of these concepts with a simple script. So suppose I have an experiment with a number of trials. Let's suppose n is the variable that contains the number of trials. I have 8 example trials, and I set up a loop from 1 to n. That's the number of trials. And for each trial, I make a decision whether to draw a condition that's value 0, where you do one thing, you show one type of stimulus to a subject, or you have the value 1 and then you do some other action. You show a different stimulus. Let's show what's happening to the screen. We print a trial, and then we print the condition that we sample. And if we run this, okay, so now I get 8 trials with, for each trial, randomly decide if it's condition 0 or 1. I can also fix the random number generator, seed the random number generator with some value. And now if I run this and I repeat running it, every time I run it, I get the exact same random sequence. One issue with this setup is that every time I run it, I might have a number of trials that's assigned to the 1 condition that's different to the number of trials assigned to the 0 condition. On average, this random number generator will give sort of a 50-50 distribution, but on small numbers of trials, it's quite possible that sometimes you get 6 out of the 8 trials assigned to 0 and 2 out of 8 to 1, and you can have quite a bit of an imbalance in terms of your allocation of trials to conditions. Ideally, you would like to exert some control and guarantee that you have a balanced number of trials per condition. So you can change the script by using the randperm function. So first of all, randperm, what does this do? If I have the randperm with a single argument 8, the result of this is that I get the numbers 1 through 8 in a random order. Now, this does not seem immediately useful, but you can use this to scramble the trials and guarantee that the trials have some fixed number, or that the overall number of conditions across trials is fixed. So let me illustrate this. So suppose I set up an array a priori with a certain number of zeros and ones. So let's suppose n again is this number of trials, and I have 8 trials. And now I set up a row vector where I have half of the n trials are assigned to 1s and half are assigned to 0s. So let me save this script and let's see what happens to conditions. So now I have 4 1s and 4 0s. I would like to randomly scramble these conditions. So this is where you can use the randperm function. So I can say, let's create a random permutation over these n trials. And now I would like my conditions to be scrambled. So now let's see what conditions looks like. So now I get this random permutation, right, of zeros and ones. But I've guaranteed that there is an equal number of ones and zeros. And now you can just follow the logic of the previous script. Let's copy some stuff over. So now I can say, well, the condition at a particular trial is basically retrieving the value from this conditions vector at the ith position. So if we run this, and I should add a semicolon here, now I have the desired result, where every time I run this experiment, I have an exact balance of ones and zeros.